these two differences, I hope from the name itself. So it should be clear from the name itself. The overhead system means it is overhead, means above the ground, and it is conducted, means the transmission takes place through the different towers and the supports. The conductor is carried between the supports. So this goes the overhead system, and the underground system is using the cables, which is the underground cables. Different kinds and different materials are there, we'll study. So these two systems are the two different types that we are going to start module wise. Our first two modules deals with the overhead transmission line. So the introductory part is over for the two classes. Now we will move on to the respective modules, deep into the modules. So the first module includes the overhead transmission lines, which is the overhead system. So is it visible to you all?
Yes, ma'am, it is visible.
Okay, okay. So the two things that we are going to study is first, beginning with the overhead transmission lines. We'll go on to the different components. What are the different things that includes in overhead system? What it needs to be studied? Those things are going to be there. So these are the different components of transmission. As we can see, this diagram, I hope it is clear. I'll just do the view full screen. Somehow it is not taking the full screen. I am making it full screen, but still it is going again. Anyway, no issues. Just wait a minute. Yeah, so now it will be visible, I hope, because I made it full screen. Yeah. Hmm. Now it is full screen. So you see, overhead transmission lines are the first thing that we are going to study out of these two, overhead system and underground system. So for the overhead system, we are entering for the overhead transmission lines. You see the diagram, right? It is, you can see two supports and the conductor or the wire is hanging between the two supports. So these two, the two tower-like structures that you see, pole-like structures, those are the supports. Those we call as supports. The wire which is marked as the wire, that is actually the conductor. Okay. So the main components of transmission lines are conductors, supports, insulators, which is obviously not visible in this diagram, insulators, and the cross arms. Okay, so there are other miscellaneous components also in transmission lines, obviously lightning arresters, phase plates, arcing horns, danger plates, anti-climbing wires. So these are the components which are miscellaneous, means it falls under others. Apart from that, the main components of transmission, overhead transmission lines, are the conductors, supports, insulators, and cross arms. Okay, now I hope you remember the previous whatever we studied, the AC system, the DC system, because it is required now in overhead lines. Whatever the total, whatever we have studied till now, that those important points I'm just telling you in short so that we can start. First of all, we studied that why it is carried on, transmission is carried on at high voltage. What are the important points? These were the points that basically what it does. Advantages were reduction in the copper loss, cross section of the conductor also decreases, reduction in the volume of the conductor material, voltage drop, voltage regulation improves. These we have done. At the same time, increase in the transmission efficiency, and it reduces the cost of power transmission over long distances. So these were the advantages. Disadvantages were like corona loss, radio interference, line supports need to be stronger, and information is required. Okay. Next is that we studied that in AC system, the AC transmission, it will be three phase, three wire system. So it is used in distribution. So this classification of AC and DC is something that we need to incorporate now. So I'm just telling you in short about, I think it is not there. Okay. So there are different types of AC and DC transmission systems. Like two wire, you if in DC you are doing it in two wire. In AC there is many kinds, like three phase, three wire, three phase, four wire. The fourth wire is the neutral. So different kinds of classification are made based on our AC and DC, which system you are choosing upon. So now, as we are entering the overhead transmission lines, there is something that needs to be remembered, that the conductors, supports, insulators, cross arms, these should have some particular features. Rather, it should be the characteristics. Okay, so I am starting with the conductors part. Conductors, you see, it is very obvious that conductors should be a good conductor of electricity. Those things I am not telling. Obviously, the properties should be high electrical conductivity, high tensile strength. Why tensile strength? That you will just understand. Anyone knows the meaning of tension? Tension. What is tension? Am I audible? Am I audible?
Yes, ma'am.
Yes.
Yes,
So
ma'am.
you have studied about forces, I think. So tension is what kind of thing? Can you explain? I'm not talking that I'm having a lot of tension, not like that. Tension in a wire or in any material, what does tension means?
Stretching, ma'am.
Right.
Whenever
So,
the two
yes, yes. Kirti say.
yes, yes, whenever between two conductors a wire is stretched more than its
Hmm.
capability, then the tension rises.
Right. Kind of right. Correct. Okay, you see why we are into the conductors and why this tension thing is needed. From tension only, tensile strength, the feature or the characteristics of the conductor, tensile strength. Why do we means consider it as tensile strength? Because of tension. It should uh, take a lot of tension. It should be able to, its capacity should be such that it can take tension. So high tensile strength. Okay, next is the low density and low cost. Obviously it has to low density and low cost is desirable in conductors. And metals, mainly the metals that are used are copper, aluminium, iron, because they can be used as conductor material, and not in one combination, but they can be used in alloys also. Means using these, a combination of alloys can be obtained, means copper, aluminium and iron. So these properties are obviously present in these three metals: copper, aluminium and iron. We all know that the best conductor of electricity is copper, right, for the conductors. So the most commonly used conductor material is hard drawn copper. Hard drawn copper. Okay. There is a thing called hard drawn and cold rolled. So those things you will come to know material wise. Hard drawn copper is the best and most commonly used conductor material. So the conductivity of the material depends upon the percentage of the impurities it contains. So it has high current density, and therefore it is for a given current. High current density means what? For a given current rating, the cross sectional area of the conductor is small. Means for a small cross sectional area of the conductor also, it can carry a huge current. That is the current density, right? So that current density is there in copper, and the metal is quite homogeneous, durable, and low specific resistance is there. So this is about the conductor part I am telling. Next conductor means preferable conductor is aluminium. So aluminium, it is lighter. Everyone knows that aluminium is light in weight. Conductivity is also 60% of that of copper. And for the same resistance, diameter is also, it's a big bigger 1.27 times that of copper, so that is okay. Now the diameter of the conductor is more the diameter, it offers greater surface area for the wind pressure and also for the sag. Now I'll just move on to the sag, because what are the terms that I am using you may not know. This tensile strength that I asked you, tension, always remember, tension and compression, these two are oppositely acting forces on anything. Tension is that you said, when it is stretched, tension exists, and compression is when it is just the opposite of stretch, it is moved inwards. Okay, so that is compression. So tension and compression are the two very important forces acting on any material. Okay, so before assessing anything about the, suppose here the conductor materials or the wire that is going, the wire itself is the conductor. So that wire, that it is shown in the figure also, when it is stretched and when it is compressed, these two forces have to be taken while considering anything related to calculation of the conductor materials. Okay, so this is the first thing, conductors. Next are the steel conductors and the ACSR. ACSR you can write down also, capital A, capital C, capital S, capital R. It is aluminium conductors, steel reinforced. Mean among all the, it means that all the aluminium conductors, steel is reinforced in one of them. Okay, so the conductor basically is formed about the combination of aluminium and steel, and it makes the use of both both aluminium and steel conductors and reduces the overall disadvantages also. So ACSR, aluminium conductor steel reinforced. I can see all the diploma students leaving. Okay, just remember that I'm already auto marking the attendance. Okay, so yes, aluminium conductors will steel reinforced. This is actually our conductor types. So copper, aluminium, steel, ACSR or aluminium conductor steel reinforced. These are all the conductor materials. Next, you can see that the next important component is supports. Supports is marked by the pole in the diagram. You can see pole or the tower-like structure that is carrying the conductor, between whom the conductor or the wire is hanging. That is the support. Now support is the next important thing. It can be wooden poles, it can be steel tubular poles, it can be RCC or reinforced concrete cement poles. Okay, obviously steel towers are mostly used, and the properties that line supports should have is that it should be again mechanically strong, it should have a longer life, it must be flexible to absorb the unbalanced load. Means it should not fall down if any unbalance of load occurs. Okay, and then the maintenance also should be low. Fine. So these are the different kinds of line supports. And next are the insulators. Insulators you'll study, there are mainly five kinds of insulator: suspension insulator. I'll give in, we will go into detail into these insulators, because insulators form a different chapter once again in this module. So insulators, as you know, obviously they should be strong, they should be capable enough to withstand the high voltage and the high current, they should be able to insulate properly. These are the properties of insulators. And cross arms are just used for the supports. In the diagram I'll show you what cross arms basically are. So these are the main components of transmission lines. And since the subject is transmission and distribution, our next thing is components of distribution. So distribution component, this is also very important, very, very important. That is they ask about what are the functions of feeders, distributors, and service mains. So you need to just remember the functions of each of these. So I'll just say in short that the components are: first, substation, then the local distribution station, third is the feeders, fourth is the distributors, and fifth is the service mains. So you see, we all know that transmission takes place. After transmission, it is voltage is stepped down using transformers, and it goes to the distribution level. Substation. So substation is the first part. If you see the diagram, I hope you can all see the diagram. There, the innermost part is the substation. Then, as you move towards the periphery, you get the feeders. And from the feeders, the last line is the distributors. And from the distributors, it goes to the service mains. Okay, so it is arranged and written accordingly. First the substation, then the local distribution station, then the feeders, then the distributors, then the service mains. Okay, so I'm just telling in short about the functions of each of them. First, the substation. We all know that transmission lines, those who are carrying in very high voltage, they are entering to the distribution by the use of transformer. So the transmission lines brings the power up to the substations at a voltage of about say 33 kV. Okay, so 33 kV they are entering at the up to the substations. Now at the substations are the places where this change occurs. Change means the transformers actually operate in substations. So if they ask you what is the main component or main element or the most important thing in a substation, that is the transformers. So mainly whatever this up and down of voltage is taking place, it takes place in substations clearly. Okay, so substations, the transmission lines, they bring the power at 33 kV, as I said, and at the substation that level is reduced to more like 3.3 kV, means 33 kV to 3.3 kV or 6.6 kV, like this it is reduced. So that is the first part of the distribution, the substation. Then using the feeders, the power is given to the local distribution station. Now we enter into the local distribution center or station. Okay, so local distribution station consists of distribution transformers. Again, a transformer. This transformer, distribution transformer, it steps down the voltage levels from the 3.3 kV, 6.6 kV, that kV to 400 volt. Now it is no more kV. It is directly volt. Okay, so 3.3, 6.6 kV to 400 volt, 230 volt, like this. Then it is distributed further using the distributors. Now comes the distributors, and this is also called distribution substation. Means the local distribution station. They can be also known as distribution substation, because it is stepped down to 400 there only. Okay. So next is that the feeders. Feeders are the conductors which are large current carrying capacitor. They have the capacity of large current carrying. These are basically conductors only. So feeders, what are feeders? Feeders are conductors that carry large current. Okay, so the feeders connect the substation to the area where the power is finally has to be distributed to the consumers. So no tappings are taken from the feeders. The feeder current always remains constant. Okay, if you have heard of bus bar, then you will okay, we will come to know about that bus bar. You will not understand now. So no tappings are taken directly from the feeders. So it is the distributors from where tappings are taken. Okay, you can see the arrows. The arrows are coming out from the distributors. Okay, so no tappings are taken from the feeders. The feeder current always remains constant. The voltage drop along the feeder is compensated by using compounding by generators. Some of the distribution generators are used there. Now is the distributors. Now the distributors, these are the conductors used to transfer power from the distribution center to the consumers. Okay, so these are the distributors. They transfer power from distribution center to consumer. Consumers are who? Us, like domestic, commercial, industrial. These are the consumers. So from the distributors, the tappings are taken for the supply to the consumers, and the voltage drop along the distributors is the main criteria for designing the distributors. Okay, and the last part is the service mains in our house where we dwell, the dwellings where we stay. There in the meter box you will find from the to the meter box where the line is first coming, those are the service mains. Okay, so they are basically, service mains are small cables, small cables that are between the distributors and the actual consumer premises, like our house. Okay, so between the distributor and the consumer premises are the service mains. Okay, so these are the components of distribution. Now we will move on to the main part, overhead transmission lines. As we are entering here, the overhead transmission lines, let me tell you, there are a few things on which we have to focus. The first thing is sag. There is something called sag that we will study now only. So sag is the main part from where we will get the calculations, numericals, everything. So be very careful, and from the starting itself try to follow and write it down, especially the calculation part. Okay, so starting with the sag part, I was talking about tension and compression. I hope you remember. So what happens? Suppose a rope, you know, rassi. That example of a rope I am giving. So for a rope, if it is suspended, means a rope is hanging suspended between two points, suppose, then it will have a tendency to sag down, means hanging will be happening in any case if a rope is suspended between two points. Okay, so similarly, when a wire or a conductor is suspended between two points, the wire sags down, means it hangs, it will hang in any case. Okay, so the wire basically takes the shape of a catenary. Catenary, you know, if you are not known to catenary, like boat shaped structures, so those are the catenary. Okay, that structure is called catenary, or a parabola to be specific. I hope you know parabola.
Yes,
Parabola.
ma'am.
Yes,
Yeah.
ma'am.
Yes,
Yes, so that shape the conductor takes. Okay, so that shape is catenary or kind of parabola, and this that is called as sag. In this diagram, you can see that S, using S, a portion is marked. The topmost part and the bottommost part of the conductor where it is hanging, that difference is marked as S, using S. I hope it is visible.
yes, ma'am.
Yes, that S is basically representing sag. Okay, sag. I'm just see the definition I've written of sag. Sag is the difference in the levels between the point of the support and the lowest point on the conductor. Anyone has unmuted? Kindly mute yourself. Okay, so sag is the difference in the level between the topmost point and the lowest point of the conductor. That is called as sag. Now, what we have to do is the calculation of sag. I'll just tell some important points related to sag. Just listen carefully. Okay. You can see the diagram. This is an overhead transmission line and it is suspended between the two supports A and B. A and B are the two supports that I was just telling a component of transmission line was support. So between those two supports, A and B, the conductor is suspended. Okay. Now the transmission line, this as you can see, it is not fully stretched, means full tension is not there, fully stretched it is not, but it is allowed to sag down. And the lowest point is O. It is marked as O. The point O is the lowest point of the conductor. Okay. Now, as I said, the difference in level between the point of support and the lowest point of the conductor is called as sag. Now, it is necessary to remember some very important things regarding sag. Okay, because from the calculation point of view, it will be important. So, when the supports, these two supports you can see, they are at same level, means A and B are at same line. So when the supports are at same level, then the shape of the conductor is in the form of a catenary. And this shape of the conductor is called sag span curve. Sag span curve. SAG sag dash span, SPAN span curve. So this sag span curve is the shape of the conductor. Now, if the sag is small, means that hanging portion is small with the span, then the sag span curve is called as a parabola. Okay. Now we are coming to the two important forces. Let me first start with tension. Tension is the force. At any point, suppose at any point, the tension will act tangentially if you are clear about it. Yes or no? You say at any point tension will be calculated by use of a tangent. Yes or no?
Yes, ma'am.
Yes, ma'am.
Yes. Yes. Are you understanding? Any questions till now? Then please ask.
No, ma'am. Yes.
Any question? Okay. So you see, for the calculation of sag, tension is has to be understood very well. Tension at any point is acting tangentially. Suppose it is at the point O, then it will go as the dotted line. The tangent is the dotted line, so it will act tangentially. Now, if it is at any other point, say where the arrow is written with conductor, say at that point, consider that point as P, suppose, then at that point P on the conductor, the tension T will also act tangentially. Now this tension will have two components, as it is we said that tangentially it will be. So it will be having two components, one acting horizontally and other acting vertically. If you remember resolution of components in case of vector, do you remember resolution of components in case of vector?
Yes, ma'am.
Means suppose T is the our tension, then the horizontal and vertical will be T cos theta and T sin theta depending upon the angle. Yes or no? Any questions?
No, ma'am.
Okay. So these two components that will be acting, one is horizontally, another is vertically. Now the tangent direction at suppose at the point O is vertical and the tension at the point O acts horizontally depending upon where the point is used. Now the horizontal component of the tension will be constant throughout the length of the wire. So the horizontal component of tension at a point O, suppose, is constant throughout the length of the wire. Now coming to that, the tension at the supports will be approximately equal to the horizontal tension acting at any point. Now, the horizontal tension acting at any point will be taken as, suppose, horizontal component H. Okay. So that will be, if that is the only component and it is at equal, means T is the tension and at the support A or B, then T will be equals to H. Means the horizontal component only will be equal to the tension. Okay. Now coming to the point of, if anyone has any idea that apart from tension, uh, if it acts horizontally, in the vertical portion, what else force can is acting? I'll be very happy if you can answer. What else force is acting vertically, not horizontally?
Gravitational force.
Gravitational
Yes,
force.
yes. So gravity means what? Weight. It's weight. Gravity means the weight only, na? Weight of the conductor. Means
Yes, ma'am.
gravity, yes. So weight per unit length will be the another force. So while calculating the sag, we will be having two things. One is the weight, another is the tension. Okay, because here compression is not acting. So obviously, there is only tension and weight while the calculation of the sag. So now, while calculating, the two external forces acting will be number one, the tension, number two, the weight. Okay. So we will be having the calculation. It's actually a big one. So let me not go into that today, because it will be too much. I'll be directly going. See, I am just telling in short. Okay. Here, there are two cases of calculation of sag. First case is when the two supports are at equal level, means A and B are at same line, same straight line. Okay. Another number two case of sag calculation is at unequal level, when the two A and B, the two conductor, two supports will be at unequal levels, and the conductor will be hanging between two unequal levels. Do you understand? Equal and unequal support level. Are you getting my point?
Yes, ma'am.
Yes, ma'am.
So these two cases, it is a big one, so it will take one more class. So I'll just finish the class here and give you this entire recording and the first part, whatever we have done till now. That also I'll share the notes, because it is very important for you to go through each of these components of distribution and components of transmission, because the functions of each of them come, especially components of distribution is important because they ask the function of feeder, distributor, service mains, and also the different qualities or features, characteristics of conductors they ask. And I think up to this much only I'll have for today. Um, Remember SAG, and also the calculation of SAG I'll try to share. Next class I'll definitely explain the calculation part. So I'll be just finishing the class here. Anyone has any question for today's class?
No, ma'am.
Okay.
No, ma'am.
Whatever. Okay, okay. Whatever is being taught, please kindly go through it. Especially, I am providing the videos for remembering, means for your remembering purpose. So do go through the videos, and notes. I'll share notes, PPT, and everything. Go through it. Okay. So I can see the attendance has reduced to 35. Okay, fine. I have taken down those who are present now. So that will be taken only. Okay, thank you, students. I'll be leaving this. I'll share the recording. I'm finishing this, ending this call. Thank you.